Hi Year 10s, today we are doing the addition rule. Copy down the notes as usual and I'll talk to you in a minute. Alrighty, so here's the one equation that you need to remember. So it says here the probability of A union B. So to find that, it's equal to the probability of A plus the probability of B and then minus the probability of the intersection of A and B. Now you're probably thinking, how the heck did they get that? I want to explain to you exactly how this works. So to find the probability of A union B, the union is all of A and all of B, including this middle section. So it's all of that in here. So it includes everything except for the ones that are outside. Okay, so what this means is, if you look at the probability of A, I'll shade that in for you. So the probability of A is that whole circle there. See that whole circle? Plus the probability of B. Now if we add in the probability of B, B is this whole circle here. So if we add those two probabilities together, what you notice, you've added that one plus that one, but what about this middle section? We've added it in twice. We've added it in once with the A and once with the B. Can you see that? We've added it in twice. So that's why we subtract one lot of the intersection of A and B. So if you subtract that once, then you've got the unions. You've got all of A, all of B, but only the middle section once. Hopefully that makes sense. Probability of A is that whole circle, probability of B, that whole circle. You've got the middle section twice, so you subtract it, and then you've got the union. Excellent. So if we look down here, remember mutually exclusive. Events A and B, or set A and B, are separate like that. So there's no overlap. It says here the probability of A intersection B is equal to 0, because there is 0 chance of picking an element where there's an intersection, because there is no intersection. Remember, it was a null set, or an empty set. And therefore, the probability of A union B, when it's mutually exclusive, is just the probability of A plus the probability of B. Because if you have a look there, there's the probability of A and the probability of B. Because there's no intersection that's doubling up or anything. Alrighty. So, let's do a couple of examples. So remember, you must know all the details about a deck of cards. Okay, so a card is selected from a deck of cards. So event A is a diamond. So hopefully you know there's 4 diamonds in a deck of cards. And B, the card is a jack. Sorry, take that back. The diamonds, there's a quarter of the cards are diamonds, so there's 13 cards that are diamonds, sorry. And then the card is a jack, there are 4 jacks, that's what I meant to say. Alrighty. So, find NA, the number in set A. How many diamonds are there? There's 13 diamonds in a deck of cards. NB, the number, how many are jacks in a whole deck of cards? How many are jacks? There's 4. Excellent. Now the last one here, the number A intersecting B. So we're trying to find out how many cards the intersection means both occurs. So that are diamonds and a jack. So how many jacks are there in a deck that are actually diamonds as well? There should be 1. There's 4 jacks, 1 diamond, 1 heart, 1 clubs, 1 spades. So there's 1. So the answer to that is 1. Excellent. Now we find the probability of A. The number in A is 13, so the probability of A is 13 out of 52, which simplifies to a quarter. And so a quarter are diamonds. So yeah, that's pretty easy. Next one, probability of A dash. Now, A is the probability of getting a diamond. So there's 13 diamonds. You can do this 2 ways. You can go 52 minus 13, which is 39. So you can go, there's 39 possibilities that are not diamonds out of 52, and you can work it out, and then simplify that over 3 quarters. But the easier way to do it is not A, or the complement of A, is the same as A, so we can do it another way, minus 1. So, because remember, the event A and the complement of A must equal 1. So So we can go 1 minus the probability of A, which is a quarter, and we get the answer as 3/4. So this is a simpler way to do it, and it shows you've got an understanding. If the probability of A is a quarter, then the probability of not A is 3/4. It's simple. Now, the probability of A intersection B. So there's one chance out of 52. So the question might say, what's the probability of randomly selecting a card, and it's the Jack of Diamonds. There's one chance of that out of 52 cards. So we get 1 out of 52. Alright, now we get to the harder stuff. It says here, use the addition rule to find the probability of A union B. Here's our addition rule up here. So I'm going to write it out for you. So the probability of A union B is equal to the probability of A plus the probability of B minus the probability of A intersection B. Alright, we've already worked out the probability of A, which is 1/4, or 13 out of 52. I'm going to leave it like that just so they're easy to add together. Okay, and we need to work out the probability of event B. Event B is getting a jack. So how many jacks are there in the whole deck? There's 4. So we've got plus 4 out of 52. Does that make sense? There's 4 jacks in the whole deck. Excellent. Now we've got to subtract. Remember that middle section, the intersection, we've added that twice from that diagram over there. So we've got to subtract 1 lot of the probability of the intersection. So the intersection here, or we've even worked it out, is 1 over 52. So we subtract 1 over 52. And that's why I left it as a denominator 52, so now you can add them together. So 13 plus 4 is 17, minus 1 is 16. 16 over 52, and you can simplify that. Alright, another way to think of this is how many cards, you can think of it logically, how many cards are there that are jacks or diamonds? So we know that there are 13 diamonds in the whole pack, but you also want to add it together all the jacks. But one of the jacks is already in this group of 13, in that suit. So there's another 3 jacks that we haven't accounted for. So 13 plus 3 is 16. So it's another way to get that same thing, just using common sense. But it did say in the question, use the addition rule. So you must use the addition rule if that was written in a test. Alright, now let's do the last question over here. Find the probability of getting a jack or not a diamond. Alright, so it's asking, find the probability of a jack. The jack is B. Or, so it means that's a union, so it means that or that, so you add them like it's adding them together, or not a diamond. So a diamond is A, but not a diamond is A dash. Alright, so now we can work out use the addition rule. So the probability of B union A dash is the probability of B, I'm going to squeeze it in here, plus the probability of A dash minus the intersection, so the probability of B intersection A dash. So it doesn't matter which order you put those two in. I could have put A dash union B, it doesn't really matter. Alright, so the probability of B, what's B? The card is a jack. Have we worked it out here? Well, we know there's 4 jacks in the whole deck, so we've got 4 out of 52 is a probability. Alright, now the probability of A dash. The card is a diamond. How many diamonds are there? There's 13 diamonds in the set. So what's the probability of not getting a diamond? It's 52 minus 13, which is 39. So that is 39 out of 52. Yep. And we already worked that out down here as well. So that was all good. And then we've got to work out minus the probability of B. So the card's a jack, and it's also not a diamond. Okay, so have a think about this. Can you see that? Because B says the probability is a jack. B is a jack. And A dash, A is a diamond as well. So A dash would mean it's not a diamond. So we've got to think, how many cards in the deck are there that are jacks, but not diamonds? Well, there's one that is a diamond, so there's 3 other jacks that are not diamonds. So that must be 3 out of 52. So we add these together, and I get 40 out of 52, and you can simplify that. And that's your answer. So have a think about that. Think about it carefully about the A dash and what I just talked about and how you get these three numbers. Go over the video if you need to. I'll see you soon with another example in just a minute. Okay guys, so I've got another example here. So it says, these are given, the probability of A is 0.4, the probability of B is 0.8. The probability of the union of A and B is 0.85. Find the probability of their intersection. Okay, so we use the addition rule. So we go, we write the formula out, probability of A union B equals probability of A plus the probability of B minus the probability of A intersection B. That's what we're trying to find. So all we have to do is substitute the values in. So we get 0.85 equals 0.4 plus 0.8 minus the probability of A intersection B. If you wanted to replace that with X or something like that, so you don't have to write that out every time, that's fine. 0.85 equals 1.2, add those together, minus the probability of A intersection B. Now, solving equations, we add that to that side and subtract that from that side, so hopefully you know what I'm doing. So I'm doing two steps in one. So the probability of A intersection B is equal to 0.35. So 1.2 minus 0.85. So doing two steps in one, hopefully you know what I'm doing. If you're not sure, just write it out. We've got exercise 8C, question 1 to 9. You can do all of them and have a go. Make sure, see me if any problems. See you later. Smash that like button.